Can you hear my voice? Good morning, everybody.
Good morning, sir.
Okay, so let us wait for 2 minutes and then we will start the class so others could join. Okay, so let us start the class. You are already 14 people. So I don't know why more students are not joining. So last day, what we taught about, any confusion about that? Yes, any confusion? I am asking to everybody. No confusion. Are you listening or not? Can you hear me?
Sir,
Okay. So there is no confusion. In the last topic. So have you done some problems? I have shown you some problems about. And have you done some problems in your home? Have you done some problem? अरे भाई कुछ जवाब दो. अगर कोई करे हो तो बोलो कि हाँ सर मैंने देखा है. अगर कोई नहीं देखा हो तो फिर भी बोलो. जो पढ़ा रहे हैं कॉलेज में क्लास में वो क्या घर में आकर देखते हो या नहीं देखते हो?
सर कल से नेटवर्क इश्यू बहुत हो रहा है सर।
क्या क्या हो रहा है?
सर बादल उदल किए हुए हैं जिसके कारण नेटवर्क बहुत खराब है सर इधर।
तुम तो बाहर हो, तुम तो घर में नहीं हो, किसी बाहर जगह से बात कर रहे हो.
नहीं सर, हम अभी छत पे आकर के क्लास कर रहे हैं, मेरा रूम में नेटवर्क धर ही नहीं रहा।
अच्छा, तो आज बादल है, कुछ प्रॉब्लम हो रहा है नेटवर्क पे. पर लास्ट दिन जब मैंने क्लास किया था उस दिन तो प्रॉब्लम नहीं हुआ. तो मैं बोल रहा हूँ कि आप लोग क्या घर में प्रैक्टिस कर रहे हैं या नहीं कर रहे हैं, इसी के बारे में आप पूछ रहा हूँ, और तो कुछ पूछ नहीं रहा हूँ. आप लोग प्रैक्टिस कर रहे हैं या नहीं पढ़ रहे? हम लोग कर रहे हैं, इसीलिए छोड़ दीजिए और कोई नहीं करना चाहते, ऐसा कुछ कर रहे हैं क्या? नहीं, इसीलिए मैं पूछ रहा हूँ आप लोगों को. अगर आप सोचते हैं कि नहीं क्या बोलते हैं कॉलेज में जो पढ़ा रहे वो कोई प्रॉब्लम नहीं, तो प्रॉब्लम हो जाएगा ना. तो आप क्या देख रहे हैं वही पूछ रहे हैं.
ये सर रिवीजन कर लेते हैं सर।
हाँ, तो वो प्रॉब्लम किया है, कुछ प्रॉब्लम अपने आप से कुछ किए हैं, क्योंकि हम तो यहाँ पर आप लोगों को 3 प्रॉब्लम्स कर दिया है. तो आप लोग क्या क्यों कुछ किए हैं? क्योंकि आप लोग अगर नहीं कुछ किए हैं तो प्रॉब्लम हो जाएगा. क्योंकि जो न्यूमेरिकल्स हम लोग कराते हैं यहाँ पर, वो न्यूमेरिकल्स अगर आप लोग शेयर नहीं करेंगे या घर में प्रैक्टिस नहीं करेंगे तो कोई फायदा नहीं. समझ गए?
यस सर।
ठीक है, तो क्या करते हैं या ना करते हैं मुझे मालूम नहीं, तो आप कर लीजिए. इसीलिए मैं बोल रहा हूँ कि आप लोग थोड़ा प्रैक्टिस कीजिए, खासकर न्यूमेरिकल्स, क्योंकि न्यूमेरिकल्स क्लास में ऑनलाइन क्लास में ज़्यादा नहीं होगा. तो इसीलिए अगर आप करेंगे तो कोई प्रॉब्लम नहीं होगा. ठीक है, तो लास्ट दिन हम लोग पढ़ रहे थे रिवर्स, वो बहुत ही इम्पोर्टेंट है. और मैंने वहाँ पर आप लोगों के सामने डिस्कस किए थे ब्रेकडाउन किसको कहते हैं, ब्रेकडाउन डायोड्स के बारे में. और ब्रेकडाउन डायोड्स के बारे में मैंने डिस्कस किया था, और उसमें ब्रेकडाउन मैकेनिज्म के बारे में हम लोग डिस्कस किए थे। तो वो दोनों चीज़ हमने डिस्कस किए थे और हमने वो कह दिए थे कि वोल्टेज रेगुलेशन और स्टेबलाइजेशन क्यों हम लोग यूज़ कर रहे हैं, ब्रेकडाउन मैकेनिज्म क्या है और कितना टाइप ऑफ ब्रेकडाउन मैकेनिज्म होता है। तो ब्रेकडाउन मैकेनिज्म के बारे में जब हमने बात किए थे तो हम लोग बोलते हैं कि जंक्शन ब्रेकडाउन होता है दो तरह की प्रोसेस से, एक है जेनर ब्रेकडाउन और एक है एवलांच ब्रेकडाउन। तो आज हम लोग जेनर और एवलांच ब्रेकडाउन के बारे में ज़्यादातर पढ़ेंगे और जानेंगे। What do you mean by Zener breakdown, or what happens in Zener breakdown, what happens in avalanche breakdown and all that things. तो आज हमारा जो है वो हमारा है प्रोसेस ऑफ ब्रेकडाउन। तो आज बेसिक इलेक्ट्रॉनिक्स का जो चैप्टर है हम लोग डिस्कस करेंगे वो है प्रोसेस ऑफ ब्रेकडाउन, और वो अगर कंप्लीट हो जाता है तो हम लोग आगे बढ़ेंगे। तो आज है अपना 12/1/2022। आज हम लोग जेनर ब्रेकडाउन और एवलांच ब्रेकडाउन के बारे में बात करेंगे। तो पहले ही हम लोग जान लेते हैं व्हाट डू मीन बाय जेनर ब्रेकडाउन। So what do you mean by Jnr breakdown? The Jnr breakdown is observed in the Jnr diodes having voltage Vz less than 5 volt or between 5 to 8 volts. The Jnr breakdown mechanism for Jnr voltage less than 5 voltage, when a reverse voltage, so last day we have drawn the Jnr breakdown, we have drawn the breakdown voltage. So let us draw that graph again about the breakdown voltage, so it will be easier for you to understand. Okay, so let us draw it. Okay, so it is done. So this is the x-axis and y-axis. Now if I draw the, sorry, if I draw the curve, breakdown curve, then it will be easier for you. And then it will be sharp. So this point is called the breakdown point, and this voltage is called breakdown voltage, and we represent it by Vz. But in avalanche, what is happening? In avalanche, this is the breakdown voltage. This is Vz. Okay, so we can write here like this. These are the breakdown voltage. Okay, this is 0, this is I, this is reverse voltage, this is here also reverse voltage, this is 0, this is I. So this is sharp characteristics. And this is gradually changing characteristics. Okay, and this is the reverse voltage. This is also the reverse voltage. Now, this is the diagram of Jnr breakdown, and this is the diagram of avalanche breakdown. Okay, So what I told, Jnr breakdown is observed in the Jnr diodes having VZ less than 5 volt or between 5 volt to 8 volts. The Jnr breakdown mechanism for VZ less than 5 volt, what will happen when a reverse voltage 5 volt or less is applied to a Jnr diode, it causes a very intense electric field to appear across a narrow depletion region. The field intensity is typically per order of 3 into 10 to the power 5 volt per centimeter. So this is the intensity. Such an intense electric field is strong enough to pull some of the valence electron into the conduction band. By breaking the field, sorry, these electrons then become free electron conduction. A large number of such free electrons will constitute a large reverse current through the Zener diode, and the breakdown is said to have occurred due to the Zener effect. Now, a current limiting resistance should be connected in the series with the Zener diode to protect it against the damage due to the excessive heating. In Zener breakdown, the breakdown voltage depends on the temperature of p-n junction. The breakdown voltage decreases with increase in the junction temperature. The VI characteristics in a reverse bias region is shown in the above figure, which shows that the characteristics after breakdown is very sharp, almost vertical. So that is the Zener breakdown. Yes, anybody, any question?
हेलो सर सर फर्स्ट ग्राफ में वोल्टेज कांस्टेंट क्यों हो गया सर
कहाँ पर?
सर फर्स्ट ग्राफ जो किए वोल्टेज उसमें कांस्टेंट क्यों हो गया वाला
Fast diode voltage constant मतलब
सर केस कर रहा पर वोल्टेज कांस्टेंट हो गया है ना
हाँ वो तो आपका शार्प वो जो डाउनफॉल है उसके बाद तो वो फिक्स्ड हो जाएगा, क्योंकि उसके बाद और क्या होगा? अगर नेगेटिव रेजिस्टेंस डायोड है तो
सर
क्या
ऐसा
होगा? या कि या
वही
ये जो वर्टिकल लाइन इसके बारे में बात कर रहे हो? हेलो,
यस सर यहाँ पे वोल्टेज फर्स्ट ग्राफ जो बना है ना ये करंट वोल्टेज से हो गया मतलब कांस्टेंट हो गया समझ में
इसके
ऐसा
बाद बात
कैसे
कर
होगा
रहे हो?
मतलब
इसके बारे में बात कर
यस
रहे हो?
सर
वही तो मैं बोल
यस
रहा
सर
हूँ। हाँ, तो मैंने क्या बोल रहा हूँ? द breakdown voltage decreases with increase in the junction temperature. So what happens? The VI characteristics in the reverse bias region is shown. It is very, which shows that the characteristics after breakdown is very sharp, almost vertical. क्यों? क्योंकि intense electric field is strong enough to pull the valence electrons into the conduction band by breaking the covalent bands. These electrons then come free electrons which are available for conduction. So a large number of such free electrons will constitute a large reverse current through the Zener diode, and the breakdown is said to be occurred due to the Zener effect. So a current limiting resistance should be connected in the series with the Zener diode to protect it against the damage due to excessive heating. In Zener breakdown, the breakdown voltage depends on the temperature of p-n junction. The breakdown voltage decreases with increases in the junction temperature. The VI characteristics of a reverse bias region, which is shown there, that shows that after breakdown, it is very, the characteristics after breakdown is very sharp and almost vertical. So you are asking me why it is very sharp and why it is constant, means after breakdown it is very much constant. You are asking that question. There is no I think there is a problem in communication, that's why I cannot uh, understand your.
तो ये फ्री इलेक्ट्रॉन की वजह से हो रहा है क्या?
हाँ, हेलो।
तो ये कांस्टेंट से फ्री इलेक्ट्रॉन्स की वजह से हो जा रहा है क्या?
वो गिरता है फिर क्यों कांस्टेंट होता है, उसके बारे में बात कर रहे हो?
यस सर।
अच्छा, मैं बता रहा हूँ बात। बाकी जो चीज है क्यों ये गिरता है उसके बारे में कॉन्सेप्ट सबका क्लियर है? सबका क्लियर है?
यस सर।
अच्छा, in case of Jnr diode, doping is high, and so if we take about the doping concentration with, so from the formula of doping concentration, do you know the formula of doping concentration? Anybody?
सर
Actually,
एडिंग ऑफ इक्वलिटी सर।
actually normal diode, what happens to the normal diode? Normal diode are moderately doped. Moderately doped. Moderately doped. But what happens? Zener diode is heavily doped. So if I take about the junction voltage of a diode, the formula for junction voltage of diode, Vj equals to Q n omega square by just a minute. Into 2 by into epsilon, where Vj is the junction voltage, Q is the charge, that is 1.6 into 10 to the power minus 19 coulomb. I write it C. Next, W is the depletion width. Epsilon is the potentiative permittivity. Permittivity. That means epsilon equals to epsilon 0 into epsilon. So, from the above equation, what we can write N is equals to 1 by, is, so we can write W square is proportional to 1 by N. That can be written as width is proportional to 1 by root over of doping, because this is the concentration. So we can get for the diode that width is proportional to 1 by root over of doping. So in case of Jnr diode, doping is high. So from the above equation, width, that is the depletion width, is less, that is narrow. So when width is less, more charge carriers are crossing the function, crossing the junction, and charge carriers contribute so more charge carriers, the charge carriers contribute more because the charge carriers have more current. There is a sharp increase in the current, and in the time current increases, voltage remains constant. That's why Jnr diodes works as a voltage regulator. Where as in normal diode, doping is normal. So with is such that less charge carries across the junction, so less or negligible amount of current is flowed. So the voltage does not remain constant for less current. So normal diode cannot work as a voltage regulator. Understand?
Yes, sir.
Okay. So you must understand this. That's why we can use Jnr diode as a voltage regulator. Or this is the application of Jnr diode as an this is the application of Jnr diode. So I am just giving this note also, so you can understand. I am writing that thing also. Please learn by heart on this. This will be the answer also for why Zener diode is used as a voltage regulator. Okay. So what I am telling? I am telling that after continuation, so in the case of Zener diode, doping is high. So from the above equation, with, that is the depletion width, is less, or we can tell narrow, when width is less, more charge carriers are crossing the junction. So charge carriers contribute more. Charge carriers contribute more. Butte more. Just a second. So charge carriers contribute more. So as because charge carriers have more current, So there is a sharp increase in current. So as the current increase, the voltage remains a constant. Voltage remains constant. So the Jnr diode can be applied as voltage regulator. But in normal diode, doping is normal. Doping is normal. So width is such that less charge carries across the junction. Negligible amount of current flown. So the voltage doesn't remain constant. So it does not work as a voltage regulator. So it can't be used as a voltage regulator. Okay. So that is the total theory. So everybody has understand the theory. Next, avalanche breakdown in Jnr diodes. The avalanche breakdown is observed in the Jnr diodes having VZ higher than 8 volt. So there is 5 volt, 5 to 8 volt, and this is always higher than 8 volt. Even though the mechanism of breakdown has changed, the device is still called the Zener diode. Now, in the reverse bias condition, the conduction will take place only due to minority carriers. As you increase the reverse voltage applied to the Zener diode, these minority carriers tends to accelerate. Therefore, the kinetic energy associated with them increases. While traveling, these accelerated minority carriers will collide with the stationary atoms and impart some of the kinetic energy to the valence electrons present in the covalent band. Due to this additional acquired energy, these valence electrons will break their covalent bands and jump into the conduction band to become a free for electron. Now, these nearly generated free electrons will now these newly generated free electrons will get accelerated. They will knock out some of the valence electrons by means of collision. This phenomenon is called carrier multiplication. In a short time, a large number of free minority carriers or electrons and holes will be available for conduction. And the carrier multiplication process becomes self-sustained. That means it will, once it is started, it is not needed any external force or external thing. This self-sustained multiplication is called avalanche effect. A large reverse current starts flowing through the Jnr diode and the avalanche breakdown is said to be having occurred. A current limiting resistor should be connected in the series with the Jnr diode to protect it against the damage due to excessive energy. The breakdown voltage, just a minute, 1 second. So the breakdown voltage in the avalanche breakdown increases with the increases of the junction temperature. So that is the avalanche breakdown. Understand?
एक बार हल्का सा सर वो हेलो सर
हाँ बोलो.
सर हम थोड़ा लीव हो गए थे सर नेटवर्क इशू के कारण सर बैक कीजिए ना स्लाइड सर लास्ट का थोड़ा सा नहीं समझ में आया था वो थोड़ा सा बता सकते हैं
कौन सा?
सर बैक स्लाइड में यही जो उसमें आप सर थ्योरी बताए थे
हाँ बोलो.
ये सर सेकंड वाला पॉइंट सर
सेकेंड वाला पॉइंट में मैंने बोला कि नॉर्मल डाइट जो होता है उसका डोपिंग कॉन्सेंट्रेशन नॉर्मल होता है. तो उसका डोपिंग कॉन्सेंट्रेशन नॉर्मल होने से उसका विथ उतना ज्यादा नहीं होता. तो उसके जो चार्ज कैरियर्स कम होता है. चार्ज कैरियर्स जो जंक्शन क्रॉस करके जाता है वो कम हो जाता है. तो चार्ज कैरियर्स जो जंक्शन क्रॉस करके जाता है वो अगर कम हो जाता है तो नेग्लिजिबल अमाउंट ऑफ करंट फ्लो इन द सर्किट. सो अगर नेग्लिजिबल अमाउंट ऑफ करंट फ्लो इन द सर्किट तब वोल्टेज डज नॉट रिमेन्स कांस्टेंट, क्योंकि जितना ज्यादा करंट इंक्रीज करेगा उतना ज्यादा देर तक वोल्टेज कांस्टेंट रहेगा. तो यहाँ पर क्योंकि बहुत ही कम अमाउंट ऑफ करंट फ्लो कर रहा है इसीलिए वोल्टेज चेंज हो रहा है, वोल्टेज कांस्टेंट नहीं रह रहा है. तो वोल्टेज क्योंकि चेंज कर रहा है इसीलिए हम लोगों को कैसे चाहिए वोल्टेज फिक्स चाहिए. रेगुलेटर इसीलिए हम लोग यूज करते हैं, स्टेबलाइजर हम लोग ऐसे ही यूज करते हैं. तो इसीलिए नॉर्मल डाइट को हम लोग वोल्टेज रेगुलेटर के हिसाब से यूज नहीं कर पाएंगे, या वोल्टेज रेगुलेटर बनाने के लिए हम लोग नॉर्मल डायोड को नई एप्लीकेशन कर सकते हैं, ये एप्लीकेबल कर सकते हैं, हमको जेनर डायोड लेना पड़ेगा।
ओके सर।
ओके so now we will study about the comparison of Jnr and Avalanche Breakdown. जेनर और एवलांच ब्रेकडाउन का कंपैरिजन। नंबर वन, नहीं, हम लोग एक टेबल कर लेते हैं, ठीक है। और यहाँ पर एवलांच। नंबर वन क्या है? दिस इज observed in Jnr diodes. Having VZ between 5 to 8 volts. Here, this is all observed in Jnr diodes. Jnr diodes having Vz greater than 8 volts. Than 8 volts. This is the first comparison. Second comparison. The valence electrons are pulled into the conduction band due to very intense electric field appearing across the narrow depletion region. So valence electrons are pulled into conduction band. Into conduction band due to very intense electric field appearing across the narrow depletion region. The valence electrons are pushed into conduction band due to the energy imparted by colliding accelerated magnetic charges. By colliding minority carriers. Okay, just a second. Number three, number third point is what? Third point VI characteristics with the Jnr breakdown is very simple. Here number 3 is the VI characteristics with the avalanche breakdown increases gradually. It is not as sharp as that with the Jnr breakdown. And number 4 is the breakdown voltage decreases with increase in temperature. Number 4 is the breakdown voltage increases with increase in temperature. In temperature. So last point is the 2 point is same for the two things. Okay, so this is the actual difference. Okay, everybody. क्या सो गए हो क्लास?
नो सर.
ओके, मुझे लगता है कि सो गया है. So that is the difference or comparison between Jnr breakdown and E. This is very important for examination. In examination, maximum time this difference is coming. So I request everybody to Learn by heart this difference because this is very important. Okay. Understand everybody? Learn by heart.
Yes, sir.
This is very important for your examination. So anybody, any confusion with this difference of avalanche and Jnr, you can ask me. I will give you 2 minutes for questioning me any confusion because we will go to the next thing. So before that, any confusion, any question, you can ask me related avalanche and Jnr. Okay, so nobody has asked me anything, so I think that is completed. Now we will go for Jnr diode. We will discuss about Jnr diode. We will discuss about some negative resistance diode, some okay, another things. We'll do some numerical analysis of Jnr diode. Okay, and then we will go special diode, tunnel diode, and all that thing. So we will discuss about Jnr diode. So Jnr diode is a reverse biased heavily doped PN junction diode which operates in breakdown region. That is the one term for Jnr diode. Jnr diode is a reverse biased heavily doped heavily doped PN junction diode which operates in breakdown region. So by this term we can define everything about a Jnr diode. Okay, clear? The reverse breakdown of a PN junction may occur either due to Jnr effect or avalanche effect. So anything can be happen. Jnr effect dominates at reverse voltage less than 6 volt, whereas avalanche effect dominates above 6 volt. And the first one should be called Jnr diode for simplicity. Both types are called Jnr diodes. The breakdown voltage of Jnr diode can be set by controlling the doping levels. For Jnr diode, silicon is preferred to germanium because of its higher temperature and high current capability. So we will use maximum silicon. So circuit symbol. So if I do the circuit symbol of Jnr diode, I will draw. So this is a normal diode, but here it is the difference. This is the circuit symbol of a Jnr diode. This is anode. This is cathode. Okay. So if we talk about the forward biasing, then what is the configuration? This is the resistance here. This is the voltage supply. And this is the Zener diode. This is positive, this is negative, this is volt, this is the resistance. The current is flowing, forward current is flowing like this, named it IF, and this is the biasing of an resistance. So when forward biasing, when the anode of the Zener diode is connected to the positive terminal of the DC source and the cathode is connected to the negative terminal, the Zener is called the forward bias. So this is forward bias. Okay. This is what current limiting resistor. Current limiting resistor. Why I use? Because it is heavily doped. So that is we are using current limiting resistor. The forward bias Zener diode behaves identical to a forward bias diode. The forward biasing of a Zener diode, the Zener diode is generally not used in forward bias condition. Another note, you can write a note. It is a very important note for everybody. You can write it as a note that Zener diode with breakdown voltage near 7 volt have the smallest Zener impedance. Okay, so this is a note for you. So where we are? Yes, we are talking about forward bias. So what we have told, what is the forward bias? When an anode of the Jnr diode is connected to the positive terminal of the DC source and the cathode is connected to the negative terminal, the Jnr diode is called it is in forward bias. The forward bias Jnr diode behaves identically to a forward bias diode. The Jnr diode is generally not used in the forward bias condition. So there is a reverse bias because we used it in the reverse bias. So the connection of reverse bias is this is current emitting resistor, this is the battery, so this is positive, this is negative, this is voltage, this is resistance, and this is what? Negative, this is positive. So this is the flow of the current. Because it is reverse bias, so this current is IR. So this is reverse bias. So if I take the voltage across this, we will get the breakdown voltage. The drop is known as Vz. This is the positive terminal, this is the negative terminal of Vz. So what I told, when the cathode is connected to the positive terminal and anode is connected to the negative terminal of the DC source, the Jnr diode is said to be in the reverse biased. The operation of Jnr diode in the reverse biased condition is subsequently different from that of the diode. Jnr diode in the reverse biased condition is used as a voltage regulator. Okay, so I think nobody has no confusions. कोई कंफ्यूजन है किसी को?
No, sir.
Okay. Now this is VI characteristics of a Jnr diode. So the VI characteristics of a Jnr diode can be divided into two parts. One is called forward characteristics. One is called forward characteristics. And another is called reverse characteristics. So first is the forward characteristics. Number one. So let us draw the diagram. So this is the forward current. This is the forward voltage. This is 0. So this is the cut-in voltage. And this is the forward characteristics. The forward characteristics of a Jnr diode is almost identical that the forward characteristics of a PN junction diode. So you can see it is almost identical. Now it is the number 2 is the that is the reverse characteristics. So let us draw the reverse characteristics graph. This is the portion. Okay. Okay, so I draw a dotted line from here. Another dotted line from here. And there is another dotted line from here. Okay. There is also a dotted line. So what are these dotted lines? These dotted line have some these values. This is VZ, that is breakdown voltage. This is the breakdown voltage. Okay. This is the reverse voltage. This side. So this is the reverse current. this side. Okay. This is IZ max. This is the knee point. Knee point. Acha. This is IZ mean. And this is I0. And this is the this is called the Jnr Region. And this is reverse characteristics. This is forward characteristics. Okay, so reverse characteristics. As we increase the reverse voltage, initially a small reverse saturation current. What is the name of this saturation current? Reverse saturation current? Yes? Anybody? Reverse saturation current is denoted by I0. This is the reverse saturation current. Okay? Reverse saturation current, which is in microampere. This order is in microampere. Will flow. This current flows due to the thermally generated minority carriers. At a certain value of reverse voltage, the reverse current will increase suddenly and sharply. This is the identification of breakdown. That means breakdown has occurred. This breakdown voltage is called the Zener breakdown voltage or Jnr voltage, and it is denoted by Vz. So Vz is the Jnr voltage or Jnr breakdown voltage. Vz is Jnr voltage or Jnr. So this is Jnr voltage or breakdown voltage. Jnr breakdown voltage. The value of Vz can precisely control by controlling the doping levels of P and N regions at the time of manufacturing a Jnr diode. After breakdown has occurred, the voltage across the Jnr diode remains constant and equals to Vz. Any increase in the source voltage will result in the increase in reverse Jnr current. The Jnr current after the reverse breakdown must be controlled by connecting a resistor R, okay. This is essential to avoid any damage. This is essential to avoid any damage to the device due to excessive heating. Excessive heating. Next is Jnr region and its importance. After reverse breakdown, the Jnr diode operates in the region called the Jnr region. In this region, the voltage across the Jnr diode remains constant, but the current changes depending upon the supply voltage. Jnr diode is operated in this region when it is being used as a voltage regulator. Okay? Understand? Understand? कुछ बात नहीं कर रहे. Hello? Do you hearing?
Yes, sir.
Okay, so understand everybody up to this?
Yes, sir.
So last thing today's class is that applications of Jnr diode. So what are the applications of Jnr diode? Anybody? Number one is voltage regulator. That is the most important part. Number two, it is used as peak clipper in wave shaping circuits. That is peak clipper. Number three, used as fixed reference voltage in transistor biasing. Fixed reference voltage in transistor biasing. Transistor biasing. And number four, meter protection against damage or from accidental application. Meter protection. So these are the applications of Jnr diode. Okay, no problem.
No, sir.
Okay, thank you. So you have no problem. So it will be very helpful for me. And thank you. Have a good weekend. We will conduct the next class on Monday. So before that, have a good weekend and study well. And be safe. Don't go outside because the COVID-19 is very much. So I am Kostakanti Mondal taking you the basic electronics from Dumka Engineering College. So hope you have enjoyed this lesson of special negative resistance diode, that is Jnr diode. So thank you very much.
Thank you, sir.
और किसी को कुछ पूछना है? हमारा क्लास 1 मिनट है. किसी को कुछ पूछना है तो बता सकते हैं. कोई भी डाउट हो तो पूछ सकते हैं आप लोग. Or you can leave the class because there is nothing to discuss. So if you have doubt, there is 1 minute, so you can clear your doubt clearly. If you don't have doubt, you can leave it and you can join the next class. So thank you.